Trigonometry. In this session, we'll see how to find the values of all six trigonometric ratios for different angles like 0, 30, 45, 60, or 90. Usually, these ratios for the angles are remembered as it is, but at times it may be required to derive these values. Now we'll see those derivations, but this is the final trigonometric table that we will get. And these values we have to remember. Coming to the first thing is when an angle is 0. We all know these six trigonometric ratios. We have seen that in our previous video. I will attach the link in the description. For all trigonometric concepts, we have to be aware about a right angle triangle. Here is a right angle triangle ABC, and all the angles will be derived with respect to angle A. And for angle A, opposite side is BC, hypotenuse is AC, and adjacent side is AB for this particular figure. This is only for reference. A triangle can be named like anything like PQR or something else, but we have to remember if we are taking a particular angle, which side would be opposite or which side would be adjacent for that. Now, when this angle A is made to be 0, means we have to decrease the angle in such a way that the measure will go to be 0. And this is how the angle will get modified. Slowly, here we can see that. So, when we try to decrease this angle A to 0, here we can observe that BC side length is also getting decreased. When the angle is 0, BC length also will become 0. Because of that, the values for all the three things like opposite, hypotenuse, and adjacent can be written like BC is becoming 0, so BC is 0, and we can see that B and C vertices are getting coincide. So AB and AC would be of same length. Now we'll try to substitute these values for the ratios. Sine 0, sine is nothing but opposite by hypotenuse. Here we have opposite to be 0. 0 by hypotenuse gives to be 0. And cos 0, adjacent by hypotenuse. Adjacent value here is AB. AB by hypotenuse is AC. When the angle is 0, P and C are coinciding. So these two values will be equal, making the value to be 1. Then for tan 0, it is opposite by adjacent. Opposite is 0. 0 by anything makes 0. Next one is cosecant 0. It is hypotenuse by opposite side. Opposite is 0. So anything divided by 0 is not defined. Here this symbol is used to represent not defined. Next for secant, it is hypotenuse by adjacent. Again these two values are same when the angle is 0. So the value comes out to be 1. Chord 0, that is adjacent by opposite. Opposite is 0. Anything divided by 0 is not defined. So the value of chord 0 is not defined. So now we have got values for all six ratios when the angle is 0 degrees. Now coming to the next angle, for the same triangle, if we want to make angle A to be 90, here we can observe when we are trying to increase the angle A, it is slowly moving towards vertex B, and AB side is getting reduced in its length. And when the angle is exactly 90 degrees, A and B vertices coincide with each other, making AB length to be 0 and AC would be equal to BC. Let us write these values here for opposite, hypotenuse, and adjacent. So AB is 0, both AC and BC would be equal to one another. Now when we substitute these values for the six ratios, let us check for the first one, that is for sine 90 degrees, opposite by hypotenuse, opposite is AC, by hypotenuse is BC, both are same, so value is 1. Next one is cos 90, adjacent by hypotenuse, adjacent side AB became 0, so the value becomes to be 0. Next is tan 90 degrees opposite by adjacent. We have adjacent AB equal to 0. Anything divided by 0 is not defined. So this value is not defined. Next is cosecant 90 degrees. Hypotenuse divided by opposite side. Both hypotenuse and opposite side are equal to one another. So this value would be 1. Secant 90 degrees. Hypotenuse by adjacent. Adjacent value is 0. So anything divided by 0 is not defined. Cot 90 is adjacent by opposite. Here we have adjacent value to be 0. 0 by anything is 0. So this value would be 0. With this, we have calculated the values for angle 90 degrees. These are the values. Next, we will try to find the values for angle 30 degrees and 60 degrees. For that, we need a right angle triangle again, and the construction should be in such a way that one of the angles is 30 and the next acute angle in the right angle triangle is 60. Here we don't know the relationship between the sides. We will take the similar piece as ABC, flip it and attach that to ABC. Now if we observe this particular figure, it is like an equilateral triangle as angle at all vertices is 60 degrees. At A it is 60, at C it is sum of 30 plus 30. We are looking for the entire triangle ACD. So 30 plus 30 makes 60. So angle at C is 60. Even at D the angle is 60 degrees. For an equilateral triangle, we know that all sides and angles would be of equal length. So let us assume the length of the sides here. We'll think this to be 2a. Now when we have this value, we also know that B is midpoint here because we have just attached two similar pieces and B acts as the midpoint. From that we can tell AB is of length A. AD is 2A, so AB would be A, again BD would be A. We'll mark this AB length to be A. Now we'll remove the triangle whatever we have kept here as extra piece. Now we have the hypotenuse AC to be 2A and AB is A. We'll try to find the next side BC. In a right angle triangle, as per the Pythagoras theorem, we know that AC square is equal to AB square plus BC square. AC's value we will substitute to be 2A square equal to AB is A square plus BC square. Now if we simplify this, 4A square equal to A square plus BC square, transpose A square to the other side, that makes 4A square minus A square, which is nothing but 3A square. So 3A square would be BC square. Take square root on both sides, that makes BC equal to root 3A. Now we have the length of BC side as well. We'll try to substitute the values, and for 30 we will try to find the ratios first. 30 angle is at vertex C. So with respect to vertex C, the opposite side is AB, which is of length A, and hypotenuse is 2A. So A by 2A gives 1 by 2 value. Now cos 30. Adjacent side for C is BC. So root 3A divided by hypotenuse, that is 2A. Root 3 by 2 is the final value here. Next for tan 30, opposite by adjacent. Opposite side is AB, by adjacent is BC here for angle C. So substitute those values and the value would be 1 by root 3. Next for cosecant, hypotenuse by opposite means 2A by A, that gives 2 as the value. Secant 30, hypotenuse by adjacent, 2A by root 3A, that gives 2 by root 3. Cot 30, adjacent by opposite. Adjacent is root 3A, opposite is A, so root 3 is the value here. Now we have got the value when the angle is 30 degrees. We will find the values for 60 degrees. 60 degrees angle is at vertex A. So with respect to vertex A, we have to take the values. Opposite is root 3A. So root 3A divided by 2A gives root 3 by 2. Now for 60, the adjacent is AB side. So A divided by 2A gives 1 by 2. Tan 60 opposite by adjacent. Opposite is root 3A by A gives root 3. Cosecant 60 hypotenuse by opposite. 2A by root 3A gives 2 by root 3. Secant 60 is hypotenuse by adjacent. 2A by A gives 2. Cot 60 is adjacent by opposite. A by root 3A gives 1 by root 3. So these are the values for 60 degrees. So far we have seen for 0, 90, 30 and 60. The remaining is 45 degrees. For 45 degrees in a right angle triangle, already one angle is 90 degrees. Of the two acute angles, if one is 45, even the second would be 45. So that makes a triangle to be right angle isosceles triangle, which means two angles are equal and the length of sides opposite to these angles will also be equal to one another. So let us assume these values to be A. Now that we know two sides, we will try to calculate the third side. Again, we will use the Pythagoras theorem here, that is AC square equal to AB square plus BC square. Just substitute AB and BC values. So AC square equal to A square plus A square. This makes AC square equal to 2A square. Take square root on both sides. AC would be equal to root 2A. Now we got the values for all three sides. So for angle A, we will try to obtain the ratios with respect to angle A. Opposite side is BC and adjacent is AB. Let us note the values of these sides and substitute them in the formulas. For sine 45, opposite by hypotenuse, opposite is A by root 2A. This gives 1 by root 2. Again for cos 45, adjacent by hypotenuse, adjacent is A divided by root 2A, that is again 1 by root 2. Tan 45 is opposite by adjacent, means A by A gives 1. Cosecant 45 is hypotenuse by opposite, root 2A by A gives root 2. Secant 45 is hypotenuse by adjacent, that is root 2A by A, and this gives root 2. Cot 45 is adjacent by opposite, that is A by A again, this value would be 1. Now we have got the values for 45 degrees. If we keep all these things together, it looks like this.